Calculus. Cool enough to have been discovered by two separate scientists and one of my favorite subjects in school. Just by a little. But behind the wonders of derivatives and integrals, there is a mastermind that controls them both. Say hello to the limit. So to explain what a limit actually does, we have to do some rewinding to algebra first. Remember that when we have a function, we have some kind of x and it turns into some kind of y. But when we have a limit, when we approach some kind of x, we approach some kind of y. Taking a limit basically means that we're predicting a function's output, just like a weatherman with their forecasts. These predictions can help us determine a function's continuity at a certain point using only three simple rules. Rule number 1, the function in question needs to have an existing output with the input. Rule number 2, the limit of the function as x approaches the input similarly has to exist. And rule number 3, the output and the limit have to equal each other. Not that hard. There is one slight problem. We know how a function exists because we can just plug in the number. How do we know that a limit exists? Let's use a poorly drawn scale and a piecewise function to help. Each side of the scale provides an approach output coming from either the positive or negative end of the function. These are called one-sided limits. A limit can exist only when both one-sided limits are equal to each other, making a balanced scale. No balance, no limit. A lot of functions that we use, however, don't have to deal with the one-sided limit problem. Polynomial, rational, and basic transcendental functions are continuous throughout all of x. That means that to find the limit at any point, we can just plug the input into the function. And there we go. So we now know how a limit works with functions. But now we need to look at the big picture. What's so important about a limit in calculus? Calculus is split into two major branches. Differentiable calculus, which uses derivatives and focuses on instantaneous rates of change, and integral calculus, which uses integrals and focuses on a sum of instantaneous measurements. The reason limits are so important with derivatives and integrals is because the two are simply limits. It may sound crazy, but if you differentiate or integrate a function using both the limits that represent them and the basic calculus rules you know, you'll end up with the same answer. As a bonus, limits also help determine whether improper integrals converge or diverge. So there you have it. Limits truly are the foundation of calculus, and thanks to them, we can take calculus to limitless frontiers. Thank you for watching.